Not showing yet. Is it coming? Can you hear me? Hello? None of you are responding? Oh, there it is. Okay. Hey, welcome to hybrid number 3 for this trimester. In class, we were talking about rational expressions. So we got these fractions with like x's on top and bottom. And hopefully, after doing 9 through 14 and 25 to 28, you guys are at a pretty good place where you understand what an asymptote is and how you can see them on the graph, and when you make a table, when I give you a table, that you can fill in some numbers. Now, all of that was with a calculator or with a graph. Unfortunately, some of the problems on the test are going to be like this without a calculator, so we need to step it up a little bit. All right, so the main two types are, what we're going to start with are the vertical asymptotes. So the vertical asymptotes are where the bottom of the fraction is equal to 0. So I want to solve that right there, and the way to solve that, hopefully this is pretty obvious to you, but we're talking factoring or quadratic formula. Quadratic formula works all the time. It's a good way to do it. I just don't like it as much, so I'm going to choose to factor. So I skipped the area model in the box, or in the diamond problem, but this gives you your two vertical asymptotes for this. X equals -2 and x equals 1. Now, the one category of vertical asymptotes, that's that right there. Hopefully that's not too bad. The other types of asymptotes are horizontal-ish. Most of the ones we do will be perfectly horizontal. I think the last example I have is just an ish one, like horizontal-ish. Like not completely flat, but close. The way to do that is what you're looking at is when x gets really big, like when you made those tables in like, what was it, like number 9 and number 10. When you made those tables, what's happening with x when it gets really, really big? So that's how to find the horizontal ones-ish. For this one, they're horizontal. The way to think about that, I think the easiest way to look at it is, well, when you plugged in like really big numbers for x, most of the equation didn't really matter that much. Like some of it dominated. Like if you plug in a really big number for x, what really matters on the top, most of the contribution comes from the 2x squared. Like if you plug in 1,000,000, yeah, 7 times 1,000,000 is 7,000,000, but 2 times 1,000,000 squared is so much bigger that it completely dominates the discussion of what kind of numbers you're getting out. So when we're talking about horizontal numbers, horizontal asymptotes, we're going to be looking at the biggest terms on both the top and the bottom. So the x squared on the bottom is important. Now I'm kind of doing some hand waving here, but the only part that matters is that. That is really the only part that matters when we're talking about horizontal asymptotes, when we're talking about when x is really, really big or really, really small. I mean, it could also be like -1 billion. That should also be considered, but the same logic goes. Now, I'm ignoring the rest of it, but this right here is not too bad.
Darwish, please come to the main office. Mohammed Darwish, to the main office.
Mohammed Darwish, to the office, please. Anyway, so we cancel the x squareds there, and what I get is 2. That is the horizontal asymptote. Now, 2 is not an asymptote. We want an equation of a line. Horizontal lines look like that. So this equation has 3 asymptotes, 1 vertical, 2 vertical, and 1 horizontal for a total of 3. Those are the most important parts of the graph, and they also tell you a lot about what's restricted from the domain. For example, if I tried plugging -2 into this, I would not get an answer. There would be an error. So -2 and 1 are not in the domain. 2 is not in the range because that is a horizontal asymptote. Don't tell anybody, but when I first started recording this video, I screwed up the words horizontal and vertical. Happens to us all, but not me because I'm perfect. All right, anyway, next one. Next one, very similar here. What we have is a fraction, a rational function here, and what I'm curious about is where are the asymptotes? They are by far the most important part of a graph, most important part of the domain and range, most important part of anything. So asymptotes. Well, let's start with vertical. Is that right? Is that the vertical? I think so. Vertical is where the bottom is equal to 0. So I'm doing this. This is going to become a common theme. What we're doing here is we're factoring. Or quadratic formula. You could do that. I don't like it, but it works great. So you'll still get the right answers if you know how to do it. Let's see. What is this one? I'm trying to do this without the area model. Just try to like picture it in my head, but that isn't right. So let me try. There's not too many options here, so that's kind of nice. Let's see if this is plus 2, this is minus 1. I think that'll work out. Yep, that looks good to me. So I skipped the area model and the diamond problem so that I could save some space here. But this tells me my two vertical asymptotes are x equals 0.5 or 1/2 and x equals -2. Those are the two vertical asymptotes. So 0.5 and -2 are not in the domain. Now, horizontal-ish. For these, they will end up being perfectly horizontal, but what we're concerned about are the biggest terms of the top and the bottom. Biggest terms of the top and bottom are 3x squared and 2x squared. If x is really, really big, that other stuff does not do anything, or hardly does anything. It will be infinitesimal. I can't even hear me say that since I'm way over here at the board. Infinitesimal! All right, anyway, so the idea here is that I'm ignoring the rest. Again, kind of doing some hand waving, but all that will matter is this first part. So the x squareds cancel out. So what's really going on here? The horizontal asymptote is at 3/2. That's not the best way to say it. The best way to say it would be like y equals 3/2. Or y equals 1.5, however you want to put it. Most of you I know like decimals better, so same thing. So 3 asymptotes for this one. Won't happen every time, but well, for a lot of them. Last 2 examples I found in the book did. Maybe they all are. I don't know. They're kind of boring sometimes. All right, last one. Last example that I have in this video. Yeah, you're getting there. It's not too bad. It won't even be 10 minutes long, I promise. It's much better than having to listen to me for 97 minutes or whatever class period was. Yeah, that's right. Hybrid is awesome. Okay, so we want to know where the, vertical asymptotes. I do those first. Doesn't really matter which one you do first, but vertical asymptotes happen when the bottom is equal to 0. I'm expecting there to be 2 because there have been every other one. They might be kind of boring here. I'm getting kind of cold. Let me go check the window. Did you figure out what it was yet? Did you factor it? No, you were just waiting for me. I knew you were. So that's how it factors. So my 2 answers, my 2 vertical asymptotes are x equals -5 and x equals -5. What's the difference between those two? Nothing. So really I just have 1. I only have 1 vertical asymptote. Yeah, it counted twice, but that didn't really make a difference. I guess it does make a slight difference on the graph, but you don't need to know that. What I'm looking for is what are the asymptotes, and if you can do this, you would know one of the vertical asymptotes, the only one, is x equals -5. Horizontal. Now I'm looking for what would dominate when x was very, very big. So here's what I'm looking at. I'm looking at the biggest terms. Now this one is a little different. Hopefully you've already noticed this. Maybe not, that's fine. The horizontal asymptotes are what happens with this as x gets really, really big. What happens with that when x gets really, really big? Well, I guess I'll simplify a little bit. It isn't as nice as the other ones. But I get 5 over x. That is the only part that really matters when x is really huge. What happens to that fraction when x is really huge? Let's say x was 100. It would be 5 divided by 100. What happens when it's 1,000? 5 divided by 1,000. What about if it was a googolplex? 5 divided by a googolplex. Well, what happens to that is it really becomes very, very, very small. Let me try my hand at that word again. It will become infinitesimal. So what this is really going towards, again, I'm trying to do some hand waving here, trying to make it easier on you. Hopefully it is. This really, it's kind of like 0. I mean, when x is really, really big, it's gone. I mean, 5 divided by 1,000,000,000 is pretty much 0. So that is your horizontal asymptote. I feel like I should do one more. I thought I had an example in here that had a horizontal-ish asymptote. Nah, you've listened to me for 10 minutes and 5 seconds. That's long enough. We'll do it on Friday.